Um, Hello, my name is Vladimir Gordiev, and today I want to show you a Batiscaph seeing tool, a tool that I do develop for quite some time. It's a tool that collects trace events, logs from Erlang node, um, and transforms it into something more easier to grasp, more understandable, displayed in a visual way. Although it's still in the early stage, it's not that useful for production yet, but let me show it. Here's the small TCP echo server that listens on a certain port and echoes back everything it receives. Right after start, it opens a socket using any available port number and reports this port back in the log. After that, it starts to accept incoming connections, logs about any new connection, and starts a new process that's gonna handle that particular client. And this new process is gonna use handler loop function. Here's the code for the handler loop function. Basically what it does is receiving data, logging it, sending it back, and start again. It also reports when remote client disconnected and kills the process. This echo server is started from the supervision tree as defined here. So this server will start immediately after start of the application. So let's start our application. I'm just running make. Here you can see that application loaded Batiscaph probe as dependency. It will report all trace events and logs using this library. Also, it reported that it started echo server on this port. Okay, let's open the web UI of Batiscaph. Refresh. Here we got a new instance that connected to Batiscaph. Let's check it out. Here you can see a usual Erlang shell on the left, but in the web UI. On the right you can see the map of the process. They grow from top to bottom as the time flows from top to bottom, just like text. Here you can see the spawn lines. One process spawns other process. And actually we can identify the shell process on this map. We can run this command, get the PID, and can immediately see where the shell process is located on the map. When we define that echo server, we have specified that it should register using his module name. We can use that name to get a PID to this process. Let's do it. Here's the PID of the echo server, but it's not displayed on the right because it's not traced yet. To start tracing, we're just selecting it by clicking. That's our echo server, that's his name, that's the function where it hangs right now. Here's the socket that connected to this process. Okay, let's try to send some data to that port and see what's gonna happen. I'm copying the port number, opening a new terminal, and calling a curl command just to make a HTTP request to that port. Here we go. As you may notice, you get new elements on the map that depict log events, and also you got a new tab here where you can see all logs. If you open the terminal, you can see the content that was sent by curl command, line by line. Okay, let's open the logs tab. Here we got different events issued by different processes. This log record was emitted by echo server, and this by its worker. And you can see this connection by spawn line, that this process was spawned by this. Okay, let's disconnect. The curl still have the connection. Let's disconnect it. If you select the process, the worker process, you can see the reason why it was closed. Client closed connection. The same reason we specified here. That's how you can observe how your code works. Isn't it wonderful?